Hello everyone, I'm Professor Rahul Jain, experienced machine learning specialist and assistant professor, researcher and gold medalist. Welcome to this session on AI models. Today we'll explore what AI models are, why they matter in 2025, how they work, what kinds exist, and how you can choose and use them in practical settings. Let's start with a basic definition. An AI model is a computational system, usually built using machine learning or deep learning, that learns from data to make predictions, generate content, or perform decision-making tasks. Think of it like this. You feed it examples, it learns patterns, then you ask it new questions and it gives you answers. In modern parlance, many of the models we talk about are large language models, LLMs, multimodal models, generative models, etc. Why is this important? Because AI models are the engine behind many applications today, from chatbots, image generation, video generation, diagnostics in healthcare, robotics, and more. Let's look at some of the current landscape and trends so you are up to date. Models are now embedded in everyday workflows. They are not just research curiosities. Multimodal models that understand text, images, audio, and video are growing rapidly. Smaller, efficient models and deployment at edge and real time are gaining importance, not just huge models in data centers. Ethical, interpretability, and sustainability concerns are moving to the foreground. Research on explainable AI is advancing. Also, the business, infrastructure, and investment side, costs of training and inference, compute demand, and hardware are being reshaped. So in 2025, AI models are very timely for students, researchers, and engineers. Data input. Models need training data, text, images, video, and sensor data. Model architecture, the computation form, neural networks, transformers, diffusion models, mixtures of experts. Training and learning. The model adjusts parameters to minimize error on the training objective. Inference and deployment. Once trained, the model processes new inputs to generate outputs. Evaluation and fine-tuning. Models are tested and often fine-tuned for specific tasks. Feedback and updating. Real-world use creates new data requiring retraining or updates. Trade-offs. Designers balance latency, cost, accuracy, interpretability, privacy, and deployment constraints. It helps to categorize the types of models so we can speak intelligently about them. Here are several types relevant in 2025. Large language models, LLMs. These are models trained on large text corpora and often extended to multimodal, which can generate text, answer questions, summarize, translate, write code, etc. For example, the most used models in cloud environments include MUF1, GPT-4o, 44.7%, MUF2, GPT-3.5 Turbo, 38.2%, MUF3, Text Embedding Ada 002, 37.3%. 4. GPT-4o Mini, MUF 33.5%. These statistics show how prevalent these models have become. Multimodal models. These models handle multiple input types, text plus image plus audio plus video, and/or multiple output types. They can, for example, understand an image plus caption plus question, or generate video from text prompts. Specialized models, domain-specific models. Rather than general LLMs, these are tailored for specific tasks, e.g., coding assistance, protein modeling, medical diagnostics, robotics control. They may be smaller but highly tuned. Edge, lightweight models. These are smaller models designed for deployment in constrained environments, mobile devices, IoT, edge computing, where latency, power, memory are limited. Generative models. While overlapping with above categories, generative models focus on content creation, image generation, video generation, text-to-image, text-to-video, etc. For instance, the growth of text-to-video models is part of today's trend. Reasoning and agentic AI. AI models are moving beyond simple pattern matching to planning, chaining reasoning, and self-reflection. Multimodality. Integrating text, vision, audio, and video makes models more powerful and closer to human perception. Smaller, efficient models. There's growing emphasis on efficiency, edge deployment, and domain-specific smaller models, rather than always building bigger ones. Ethics, explainability, and trustworthiness. As models spread, ensuring decisions are interpretable, fair, and safe is increasingly important. Infrastructure and cost dynamics. Training huge models is expensive, but inference and deployment costs are dropping, reshaping business models and accessibility. Embedded AI and ubiquity. Models are now embedded across everyday apps, from office suites to mobile and industrial systems. Since you're in the academic educational space and might develop or teach AI, here are practical criteria to consider when picking or designing an AI model for your task. 1. Task specificity. What is the exact task? Text classification, text generation, image recognition, video generation? The model choice must align. 2. Data availability and quality. Do you have enough clean, representative data? If not, maybe fine-tune a pre-trained model instead of training from scratch. 3. Latency, throughput, deployment constraints. If you're deploying on edge or a mobile device, you may need a lightweight model. For cloud heavy-duty, bigger might be okay. 4. Cost, compute budget. Larger models cost more for training and inference. Choose something that your budget can support. 5. Interpretability and safety. If your application is in a regulated domain, healthcare, finance, legal, you'll need models that allow reasoning and transparency. 6. Multimodal versus unimodal. Does your task require multiple inputs, text, image, or only one? Choose accordingly. 7. Maintenance and updating. Plan for how you will monitor, update, fine-tune the model when new data arrives or performance degrades. 8. Ethical privacy, legal considerations. Are you handling sensitive personal data? Do you need to anonymize, ensure fairness, avoid bias? Let's bring this together via a hypothetical scenario to illustrate how each of these pieces plays out. Scenario. You are teaching an AI course and want to build a multilingual chatbot tutor for students in India, which can understand English and Hindi, respond to student questions, text, and generate illustrative diagrams, image when needed. Step by step. Task. Multilingual Q&A plus visual illustration requires text input in English and Hindi and potential image output, so a multimodal model is appropriate. Data. Collect student question-answer pairs and diagrams linked to concepts. Model choice. Pick a pre-trained LLM that supports both languages, or pair with an image generation model, or use a multimodal model. Deployment. Web.mobile access requires reasonable latency, cloud inference, or a lighter mobile model. Budget. Choose a model with acceptable cost. Many lightweight, mid-sized models exist in 2025. Interpretability. For education, ensure correctness and fairness across languages. Ethics. Privacy. Anonymize data. Obtain consent, and guard against harmful or biased outputs. Maintenance. Monitor responses, gather feedback, and periodically retrain or fine-tune. This illustrates how theory maps into practice. It's important to highlight that the field is fast-moving, and there are still significant challenges. Understanding these will help you design better educational content and prepare for future work. Hallucinations. Models can produce plausible but incorrect answers. Bias and fairness. Skewed training data can reinforce biases. Explainability. For many deep models, why an output was given isn't obvious. Resource consumption and sustainability. Large models consume significant compute and energy. Generalization and reasoning. True human-level reasoning remains an open challenge. Regulation and governance. Legal and ethical frameworks are evolving. Human-AI collaboration. The future is likely humans and AI working together. Unexpected behaviors. As models become more agentic, their behavior can be harder to forecast. Let's summarize the key points you should remember and pass on to your students or integrate into your learning. An AI model is the central engine of modern AI systems. Understanding its architecture, data, training, and deployment is critical. In 2025, The landscape emphasizes multimodality, reasoning, efficiency, embedded deployment, and ethics. Model choice isn't about biggest alone. It's about right-sized for your task, budget, latency, data, and ethical constraints. As future-facing professionals, build fluency in how models work, evaluate them, deploy them safely, and fine-tune them for domain-specific tasks. Be aware of the challenges: hallucinations, bias, sustainability, regulation, and aligning AI with human values. And encourage experimentation and critical thinking. Test models, evaluate outputs, challenge assumptions, and teach students to question how and why, not just what. Thank you for joining this session on AI models. I encourage you to continue exploring. Pick a recent model, for example from the top 9 large language models in 2025 list, and dig into its documentation. Try fine-tuning a small model on your own dataset and observe the trade-offs: accuracy versus latency versus cost. Discuss and think about ethical implications. How would you deploy a chatbot in a classroom? How would you ensure fairness across languages? In your projects, emphasize interpretability. Ask, why did the model make this decision? Stay updated. The field is evolving fast. New models, new architectures, new deployment options are emerging constantly. If you like, I can provide a slide deck outline for this topic, ready for classroom use, with speaker notes. Would you like that? Thank you once again. I'm Professor Rahul Jain, wishing you insightful learning in AI and machine learning. Professor Rahul Jain.